about line clipping in 2D, and we had discussed Cohen Sutherland line clipping algorithm, the procedure for the same. Let's discuss an example of the same today. Let us consider this is a window area. This is a window area, and we have to identify and there are three lines. One is AB, another one is this is CD, and one more is EF, and we have to find out which portion of these three lines we have to retain. And suppose this is a window area and the coordinate of the three lines is given to us, and yesterday we had already discussed that we have to assign a region code to all these points, point that lies on the left of the window, right on the window, top of the window, and above the window, and below of the window and window area. And the region codes were that we had discussed yesterday, and we always assign 0 0 0 0 code to this window area, and 0 0 0 0 0 1 to this area, 0 0 1 0. This 4-bit code is helpful for finding whether a line is visible, whether a line is candidate of clipping, or whether we have to discard the line. In the similar way, the region code of this point is 0 1 0 0, and for this is 0 1 0 1. For this is 0 1 1 0 1 0 0 for this point, 1 0 0 1 here. The similar manner, 1 0 1 0 is the region code of this portion. So first of all, what we have to do, we have to find the region code of all the end points of the line. So for the line A, the region code is 0 0 0 0. Also the region B also lies inside the window boundary, so the region code of B is 0 0 0. In the similar way, the C also lies inside the window boundary, so the region code of C is 0 0 0 0. The D lies here and its region code is 1 0 1 0. So we'll write here 1 0 1 0. The region code of E is, that is 1 0 0 1, and the region code of F is 1 0 0 0. Now, to check whether the line is visible, and we have to save the line, and whether the line is not visible, that we have to discard the line, or line is partial visible and we have to find the intersection point of that line. Here we can easily check that AB line lies inside the window area, so this line is visible. Some portion of line CD is inside the window area and some portion is outside the window area, so we have to clip this line. We have to clip the line CD. And EF line lies outside the window boundary, so we have to discard this line. This line is not visible inside the window region. So for identifying whether the line is visible, whether the line we have to discard, for that we had discussed that we have to perform the logical AND operation on the both ends of the line. And we had discussed yesterday, if the region code of both end points of a line is 0 0 0 0, then we have to save the line. And here you can easily check the region code of both the points A and B is 0 0 0 0. So we have to save this line. This line is not the candidate of clipping. This line is not the candidate of clipping. So we have to perform the AND operation on C and D. So here we are performing the AND operation for that same. We know that 0 0 0, and if AND operation, if both the inputs are 1, then output is 1, otherwise the result is always 0. So here the result is 0 0 0 0. In the same way we will find the perform the logic and perform operation on the both endpoints of EF. If the after performing the logical AND operation the result is 0 0 0 0, then line is partial visible and that line is candidate of clipping. We have to find out the intersection point of that line with the window boundary. If the result is not 0 0 0, then we have to discard the line. Here the result of EF line is not 0 0, so we will not save the line EF and we have to discard the line, discard the line EF. Here the region code of C and D is 0 0 0, so this line is candidate of clipping. Now yesterday we had discussed if we have to clip the line, then how we can do it. For that we have to use the equation of line, and clipping of this line CD is to be performed with the top boundary of the window. The clipping of this line is to be performed with the top boundary of the window. First of all we will find out this is the equation of line. Equation of line is x is equal to y minus y1 divided by m plus x1. Otherwise the equation of line is y minus y1 is equal to m into x minus x1. But this equation is used if we have to clip the line with the left or right boundary. If we have to clip the line with the bottom or the top boundary, then we have to use this equation. This equation we have interpreted this equation from this equation. This is y minus y1 divided by m. So here x is equal to y minus y1 divided by m plus x1. So for doing that, first of all we have to find the slope of the line. Here m is the slope of the line. First of all we will find out the slope of the line. For finding the slope of the line, the formula is m is equal to y2 minus y1 divided by x2 minus x1. We have to clip the line CD. So we will find the slope of the line CD, that is 8 minus 5 divided by 3 minus 1. So the result comes out to be 3 divided by 4. Hence the slope of line is 3 by 4. Now we will find the new coordinate of x, that is x is equal to y minus y6 sorry, here I forgot to write the window's boundary. So the window boundary here is minus 3 1, and here it is 2 6. The value of the y here is, in this equation this y is otherwise y max. If we have to clip it with the top boundary, then we have to use y as a y max. If we have to clip it with the bottom boundary, then we have to use a y is equal to y min. Here y max is 6, otherwise y min is 1 here. So we'll use the equation 6 minus y1 is 5, that is a coordinate of C, y coordinate of the C, divided by m, that is 3 by 4, plus x1, that is a coordinate again, x coordinate of C, that is minus 1. So after solving this equation, the result comes be 1 divided by 3 divided by 4 minus 1. So this is 4 divided by 3 minus 1. The result is 1 by 3. Hence the value of x is 1 by 3, and the value of y, we know that this is equal to 6, that is a top boundary of maximum value of y in the window. Hence the new coordinates of the line CD are 1 by 3 comma 6. So in this case the situation is now like this. This was our window area, and we have retained the line AB, and some portion of line CD is retained. The line EF is completely discarded and line CD is clipped as per our requirement according to Cohen-Sutherland line algorithm. Thank you.